The next digital circuit type is a sequential circuit. In that, see the first SR latch. Before going to explain the SR latch, I would like to explain first the NAND gate operation again. So Y is equal to A dot B bar. So exact opposite operation of the AND gate. This is the symbol of NAND gate. Two inputs A and B, output is Y. So check the conditions. If both inputs are 0, output will be 1. In the next case 0 1 1 1 0 1 and both inputs are 1, output will be 0. So what happened in this case? If any one of the input is 0, output will be 1 and both inputs are 1, then output will be 0. So remember this operation of NAND gate in order to check the operation of latch flip-flops. Coming to the circuit of SR latch, the SR latch includes two NAND gates 1 and 2. So input to the first NAND gate is output from the second NAND gate and input to the second NAND gate is output from the first NAND gate. So this is the SR latch, which is called as 1-bit memory cell, since it stores the digital number either 1 or 0. So it is called as 1-bit memory cell, which includes the digital informations either in 1 or 0 form. So see the operation starting from this Q. Assume Q is 0, then R will be 0. Any one of the input is 0, NAND gate output will be 1. Then this one goes to the S input and output will be 0. Satisfies the condition. Now the second assumption, if Q is 1, then R will be 1. Any one of the input is 1, the output will be 0 and the S will be 0 and then Q will be 1. So this is one input NAND gate. The second condition is also satisfied. Now see the next condition. If circuit is switched on, so initially S is 0, R is 0, or we assume that the both inputs are equal, either 0 or 1. What will happen in this case? This case is unstable state, or this state is unpredicted state. So very difficult to predict the outputs Q and Q bar if both inputs are same. So this condition will happen in the initial state or when the circuit is switched on, then the output will be fluctuated. I mean to say, if both inputs are either 1 or 0. So to avoid this condition, this latch is again modified, or the latch is changed to the SR flip-flop. Now moving to the next topic, SR flip-flop. This is now see the SR flip-flop circuit. This is SR latch and input to this latch is applied through the NAND gate. S is applied through NAND gate. R is also applied through the NAND gate. So this is 2 input NAND gate. This is 2 input NAND gate. So what happened? See the operation of this SR flip-flop. If S is 0, R is 0. So one of the input is 0, output will be 1 and 1. Then based on the present state, that is Q will be 0 or Q will be 1. So exact opposite will be Q bar. So based on the value of Q and Q bar, the operation will be performed. Means if it is 1 and this is 1, so operation will depend on the second input based on the present state. Either it is Q is 0 or Q is 1. So the operation will depend on that condition. So this is simply a normal SR latch operation will be performed. Since the first input is 1 and 1, so totally depends on the second input, the Q and Q bar will be generated accordingly. Now see the next condition. If set is 1, R is 0, means this is 0 and this will be 1. At that time this is 0, means Q will be 1 and Q bar will be 0. Now see the third condition. If S is 0 and R is 1, then this will be 1, this will be 0, so Q bar will be 1 and Q will be 0. So this is set and reset condition. If set is 1, output will be 1. If reset is 1, then output, the circuit output will be 0 and Q bar will be 1. Now check the last condition. If S is 1, R is 1, then what happened? The output of first and third NAND gate will be 0, and as we know that as per the truth table of NAND gate, if any one of the input is 0, the compulsory output will be 1. If S is 1, R is 1, the output of 1 and 3 NAND gate will be 0. So it doesn't depend on the second input. Since any one of the input is 0, output is 0 of the 1 and 3rd NAND gates, then compulsory the output will be 1, which means that this condition is prohibited condition or avoided conditions. We cannot predict the output. So see the truth table of this SR flip-flop. If set is 1, R is 0, Q will be 1, Q bar will be 0. If the set is 0, reset is 1, then circuit will be reset, that is Q 0 and Q bar will be 1, and both are 0 will normally work as SR latch, and if both input are 1, then this condition is prohibited condition or avoided condition. So to avoid this condition, means S is 1, R is 1, then we cannot predict the output, that is avoided completely. So to solve this issue, the SR flip-flop is again modified, and from this the JK flip-flop is developed. So the JK flip-flop will be explained in the next part. Thank you.